Now that is one sexy piece of hardware.
Hey, welcome back to Tripod's Garage. Well, in this video, we're going to kind of pick up where we left off on the last video. The last video was a budget-friendly direct drive kit for your Ender 5 Plus. It was made by printermods.com. Now, I had like three things I didn't care too much about it. First, the stepper motor was hanging over the front. Second is the extruder is facing the back so you can't see it. And third is the fit and finish. The BL Touch bracket didn't line up. But it still worked, and it still worked really well. Now, is there another solution for around the same price point? I think there is. And I think you may know what it is with the box behind me. MicroSwiss reached out to me and sent me something that's been long anticipated, and I can't wait to put it on here. It is the MicroSwiss Direct Drive Extruder. Yes, it is finally out. And there's two variants of this package. This is the full kit with the all-metal hot end, and you could just get the regular kit, just the direct drive. Now, I say that we just hop on the computer real quick, just check out the differences, and then we'll come back and see what steps are needed to complete this task.
First, while we're on MicroSwiss's site here, I wanted to take a look at the all-metal hot end. That's only for $63.50. Now, I did a video on this not that long ago on the upgrade process and the quality of this hot end. And to me, it's a no-brainer for the cost and everything, and with the hardened steel nozzle, it is a great purchase. Now let's go ahead and take a look at the extruder kits here, because I want to point out something. When we click on it, and I want to point out, let's go to extruder only. This is $57.75. I mean, you get the dual drivetrain, hardened tool steel, CNC precision cut gears, adjustable filament grip, easy filament loading. It's lightweight aluminum. I mean, honestly, right then and there for $57.75, that is a great deal. But now let's click on with the hot end, because this is what really makes this a bargain. Remember, $57.75, right? And we click on with the hot end, $99.75. So if we really want to break this down, you're now getting that all-metal hot end at discounted price at $36.25. So, and you get everything here. So anyways, I think that's a really good deal. So let's go ahead and begin the installation process. All right, let the upgrade process begin. What we're going to do is first heat up the hot end, extract the filament, let everything cool down, and power off the printer. Now, what I'm going to do is in the upper right-hand corner, you're going to see a hot end upgrade video. Now, I'm not going to go through all the detail in here because I've already got two videos that cover this. So if you need more detail on how to remove everything off of this, please refer to that video. Otherwise, I'm going to be fast forwarding through a lot of this. So please sit back, enjoy, and prepare to fast forward, just like in Spaceballs. Let's remove the extruder. Start by removing the clip, and then we are going to unplug the extruder as well as the filament burnout sensor. After we're done with doing that, we are going to unscrew the folding tube and remove that, and then we'll loosen the two screws for the T-nuts on the back and remove the whole extruder assembly. all comes off in one piece. Easier to work with this way.
Now there are some tools that you're going to need for the job. You're going to need a Phillips screwdriver, an adjustable wrench. You could, if you have one, it's not necessary, but if you have a torque wrench that does inch pounds, that's great. A 7mm socket. The wrenches that came with your printer should suffice, as well as you'll need a 2mm Allen, a 2.5mm Allen, and a 3mm Allen. Most of them should have came with your printer, so if not all of them. So,
okay, let's take a look at what's in this box. It really looks like it's overflowing, and oh well, it definitely is. Let's see what's in here. Well, definitely have you got a nice little some swag here. You got your MicroSwiss sticker here. Tells you where to follow on Facebook and Twitter. Step-by-step install instructions, and yeah, there's a lot of parts here. Let me go ahead and dig through this and lay them all out for you. And there is everything. All right, let's get to assembly. Now I wanted to mention this piece. This is a filament guide piece. This piece will actually replace your whole extruder, just to help guide the filament. Now I'm not going to be using this piece, but I will show you in the video where it goes and how to use it. I actually came up with a different solution for my filament runout and everything, and a different location. I'll also show you that in this video as well. Okay, the first thing we're going to do is take this whole extruder apart. We're not going to reuse anything but the stepper motor. Everything is going to be gone, including the gear on the stepper motor. So let's get to it. May want to sell the components on eBay or something. Who knows? Now let's take apart the carriage. And actually, we're only saving the wheels and this eccentric nut, nothing else. So let's tear it apart. We're going to start assembling the wheels. It's nice seeing that these bolts already come with thread lock on them already. Now when we assemble these, we are going to have the wheels on the standoffs. These are pre-spaced, so we don't have to worry about having those spacers. We're going to assemble it, put these in, and the eccentric nut will be the spacer for the one on the bottom. For the single wheel on the bottom, we're going to leave this nice and loose. That way it is really easy to get onto the carriage and tighten up. We are going to now install the stepper motor. This will require only 3 screws to hold this in place. The 4th screw will be with the lever. So let's go ahead and dig out the 3 screws that are needed, and I'll give you a little zoom in shot of what it looks like. Here's what it looks like with the 3 screws in place, 2 on the top and 1 on the lower left. Now we're going to install the tension lever. You're going to want to grab a piece of filament here, and what this will do is help line up the gear on the stepper motor with the one on the lever arm. You can see this flat side out. It'll just make it easier for when we put the gear on. And we're going to loosen this grub screw, and then we're going to slide this pinion gear, or whatever you want to call it, this gear on the stepper motor, tighten it down, and using again the filament as our guide. And here's a close-up. As you can see, it just really helps with lining up the gears. Now we're going to insert the lever pin. This is adjustable for the tension. So this is actually keyed and it can only fit in one way. So you can see here, so we slide this in. I'll turn it to the side here, but yeah, it just slides right in. And then pretty easy, straightforward. And then you close it, and then we're going to screw on the end cap here. Now, of course, it does say that if you're using like a flexible or something, this would be a lot less pressure to get this to push through. So just throwing that out there. It's also part of the instructions. It says that. So let's continue forward. Now this is a pull instead of a push to get your filament through. So let's go ahead and get this hot end assembled. Now the heat brake goes in on the top. So how you know that is when I pointed down at the bottom to the rub screws. So we're going to go ahead and tighten this down nice and snug. And then after we do that, we're going to insert the nozzle on the bottom and just make that nice and snug as well. Now I'm reusing my hardened steel nozzle. It's not part of this kit. So, you would of course be using the one that came provided. After we insert this, we're going to just make this nice and snug. We don't want to over tighten this. Now we're going to just insert the heating block into the cooling block, and then we need to find the little rub screw that's in this bag and then tighten that down into the cooling block, securing both of the pieces together. Now this kit comes with a notched piece of Capricorn tubing. It's very important that we line up the wedge that's on the top here with the wedge that's on the, you can see it right there on the top, that needs to line up exactly the same. So after we have this lined up, we are going to make sure this is pushed in nice and tightly into the cooling block, and then we're going to insert the clip and then push it down again. So this way we know that it's as far down as it'll go and it's not going to. Go ahead and fasten it down with the 2 screws provided. Again, it's aluminum, so don't over torque this down. Now you don't want to over tighten these, but wow, I mean, this thing together, it's going to be a shame to put the fan cover back on here, because this thing actually just looks pretty darn amazing. Well, let's get it installed. Please just double check that the machine's still powered off at this point. As you recall, the nut and bolt on the bottom is nice and loose, so getting this on shouldn't be that big of an issue. And we're going to tighten this down, this nut and bolt, and we are going to then, for fine tuning, adjust the eccentric nut in the back. This will get rid of any wobble and make sure that this carriage moves nice and freely back and forth, and you can also tilt it back and forth to confirm that all the wobble is gone. We are now going to install our belt on both ends, and most likely it is loose. I printed this part out. You could actually refer to my last video about it to help with belt tensioning. We're going to loosen these 2 nuts or bolts on the end here, and then once we do, we can apply pressure to this printed part and then tighten those bolts back up again. After you believe that you achieved proper tension, move the carriage around and tighten the tensioner back up on the ends. And you're done. I have my old heat block here. I just wanted to get a close-up on what I'm doing. I'm going to be inserting the thermistor wire, the probe right here, into the small hole, and then I'm going to take a screw and tighten it down right there, holding the wire in place. So you want to make sure that this wire isn't too tight, because we don't want to pinch the wire. Well, let's go ahead and get this final assembly done. This way we could heat it up, do some more torquing down of some screws, and get some prints going. What do you think? We need to turn on the printer and set this hot end to 220 degrees to do some final torquing of the components. We're going to take our crescent wrench, hold the heat block, and we're going to torque this nozzle down to 30 inch-pounds of torque. Now, if you do not have a torque wrench, don't worry about it. Just use your best judgment and make it nice and tight, not over tight though. Now we're going to tighten the grub screws on the heat block, and then we're also going to tighten the grub screw that's holding the thermal brake in place. So after we're done with that, we can then let this all cool down and unplug the printer and do final assembly. Don't forget to put on your silicone sock for protection, of course. We are now going to take our extruder extension cable and we're going to plug it into the back of the extruder here. And since we have wires and everything going everywhere right now, I'm going to take this opportunity to straighten everything up and also feed the filament through the extruder as well. So let's go ahead and get this going. Now we're just going to take the extruder extension cable and plug it into the extruder wire. Done wiring the extruder.
You want to make sure that your Bowden tube is right there at the edge. You can just see it right there. Then you're going to take your E-clip that was supplied. This is going to help lock your Bowden tube in place. Just like that. Here's the filament guide that's provided by MicroSwiss. It just takes 2 screws and 2 nuts on the back. Basically, this just is a guide. It replaces your extruder, and you hook your Bowden tube up to here, and you just mount it back up. Now, I went a different route with mine. This was in my last video. I basically just mounted the filament runout sensor there, tapped 2 couplers in there, and it's been working very well for me. If you like, I'll put the video up above and the timestamp of when I did it, so you can take a look yourself. Again, this is the standard way of doing it.
Now we're going to look at step 26. It's recommended by MicroSwiss to change the E-steps to 130 as our starting point. To do that, we're going to use Printerface to communicate from our computer to our printer. And there's plenty of YouTube videos on this, on how to do this, so I'm not going to bore you with all this, but this is what I'm going to be using to communicate and do the G-code command to change the E-steps, as well as do a step called PID tuning for our hot end. So let's get started. Now that we have basically replaced the whole hot end on this 3D printer, I think it's best to do what's called a PID auto tune. I opened up Printerface and I'm going to connect Ender5 Plus to this. And we're going to run a M303 command, which is going to initiate this auto tune. Basically what it's going to do, it's going to cycle your hot end. It's going to go up to a certain temperature, drop back down, and then go back up again. Find the variables, and we're going to get a new set of parameters that we're going to enter. So we're going to watch this and make sure that it completes, and then I'll show you how to enter those variables in.
A few moments later.
Now that the printer is done cycling through, it came with these three parameters for KP, KI, and KD. We need to now enter these as our new PID settings. Now we're going to enter the following command, M302 space P37 period 14 space I4 period 08 space D84 period 58. Then we will hit send. Then we're going to save this with the M500 command and then hit send again. Now we're going to change the E-steps to 130. To do this, we're going to enter the following command. We're going to type in M92 space E130 send. And then we're going to do the M500 command again to save. Now, you could have done both of these at one point to save both of them at once for the M500, but you know what? I just did this anyways. I already had the screen recording for it. But anyways, let's get to some test prints and see how this thing is working now.
Hey, pretty cool, huh? Yeah, pretty cool. Can I get a high five? Can I get a high five? Yeah. Time to go over some print results here, right? Okay, well, so one of my favorites here is the PETG carbon fiber by PRILINE. Once again, does a great job. No problem. This was from my last settings. Just went right over and looks pretty darn good. So then I did a PLA, Sunlu PLA. Now, if you recall my last video, I'll just throw it up there. I had lots of stringing. Well, there's only one string in this one, and this came out pretty darn nice. And then, of course, a calibration cube. Can't complain here either. Maker's Muse clearance and tolerance test. How do we do this time? Well, as you see, 0.5 works no problem. 0.4, no problem. 0.3, no problem. 0.2, no problem. And 0.15. Yep, I even took a pair of pliers to it. Did not want to break free. I mean, if you look at it, it looks really like it was going to. But the bottom had other ideas. So, looks like tolerance was just a little bit too tight. So, looks like I have some adjustments still that need to happen. But, still not too bad. So, now I wanted to go back into TPU. I decided to print out this tire. It's actually only about 65% size. This took about 33 hours to complete. I have to admit, man, this came out really nice. I mean, you don't see any stringing at all. It's a run flat tire, but it doesn't squish. That is actually, to me, a lot of rolling mass. If you're going to put this on an RC car, yeah, I mean, considering this is actually smaller, I would not use this on a high-speed or off-road machine. That's just a lot of rolling mass on your differential. But no, nevertheless, I think that's a really cool-looking print. So, and if you recall my last video, I did this iRobot Roomba tire, and wow. This doesn't even look the same, how And I'll put the comparison video in the upper right hand corner. Yeah, this came out great. I mean, like PETG carbon fiber. So you can see how shiny it is, but no complaints on that at all. Came out really nice. So I said, okay, let me do a lizard. So I did a nice little lizard here. Actually, it's a gecko. Very nice. I have no problem with adhesion at all with this TPU. It's got a little bit of a wisp from a couple of them on the top, but it's hardly, I didn't even notice it until now. This one I knew about, but these two I didn't. Then I decided to go with purple. This is some Yoyi, Y-O-Y-I. I don't know. But again, you know, layer adhesion is no problem. Flex is nice. This came off pretty clean, except for, again, right where the nozzle lifted off for the last time. So, really like this color. And this is when it's becomes solid. So then you have the infill, and then where you see that line, that's where it's all solid. So when you have the translucent, you actually will see it more. But yeah, I think it's pretty darn cool looking. So definitely worthwhile to print in different materials. Okay, well, let's go ahead and wrap this up and get my final thoughts on the MicroSwiss Direct Drive Kit.
Ah, almost forgot. One final part. Yeah, this file is available on their documentation. It's an extruder knob. Printed this out. Looks pretty darn nice. So this way you could just manually load the filament if you so choose. Let's go ahead and snap this on as our finishing touch.
Well, there you have it. The direct drive and all metal Hotend from MicroSwiss. What are my thoughts? Was the assembly easy? How's the fit and finish? Is there needs for improvement? So, well, let's talk about the assembly first. I thought the assembly was very straightforward. Granted, I've already done a Hotend swap before on this and a direct drive setup that was very similar. And both of those video links are already in here for you to reference, or you could just check out my channel for those. Otherwise, yeah, the online documentation, all the steps were very well laid out, color pictures, easily to reference, all the parts were labeled. Yeah, I had no problems with it. The only thing I didn't see was where the BL Touch goes, but it's kind of a no-brainer. It uses 2 screws and you just mount it back up. Now you do have to change your E-step values, and I did that 130 and it worked perfectly on this machine. While I was in there, I did do the PID tuning, which is not in there, but I highly recommend that you do, just to make sure that you have even temperatures on your Hotend. Doesn't take long. Between the two processes is less than 5 minutes. So I would definitely do that if I were you. So now fit and finish. When I saw that back plate, it was like artwork. I mean, it's so nice to look at, the precision milling and cutting. It was such a shame to put this ugly fan shroud back on. It kind of destroyed the look. But every component fit together with precision. I like the fact that the motor hangs off the back. You can see the filament in the front. Everything loads easily. You print out this knob, you could turn it, and I mean, honestly, it is so precisionally cut that I never had such an easier time to load and unload filament until now. it's now not a problem. So yeah, it's honestly, if you take a look, I mean, it just, everything just fits. Now, of course, I think there is two things that I caught on kind of early. One is this little E-clip that holds in the bottom tube. Okay, honestly, I see how it works. It does. However, if you ever put together an RC car kit back in the 80s and 90s before these were all pre-built, those E-clips were everywhere in the assembly process. And I'm telling you, there's a name for those. Even RC Sparks channel calls them this, as well as I have done. They're called Jesus clips, because when you try to snap them in, they fling out and you're like, oh geez, where'd they go? And you're hunting for that thing. This isn't that bad, but you push it in, you better make sure it's nice and firm, and it'll hold that tube in place. But when you want to remove it, you're gonna need some needle nose pliers to take it apart. Second thing is, when I was doing the auto bed leveling, it did collide with my precision binder clips that hold this nice plate on. So yeah, you may experience that because it does move your nozzle tip a little bit forward. But honestly, those are the only two gripes I have. It'd still be suggested that you feed, since this is a direct drive, you feed it from the top, not through a whole boat and tube setup. I mean, it honestly just makes more sense to have it, a spool off to the side or on a shelf somewhere. I'll get to it at some point and do that myself. Otherwise, I'd like to know your comments on this direct drive. Please comment below. I will be doing a comparison video between this and the other one that I just did. So please be on the lookout for that. I really appreciate you tuning in. If you could please subscribe, that would be great. It lets me know that you enjoy the content on this channel. And thanks again for watching Tripods Garage. Have a great day, evening, or weekend, whenever you decide to watch this video. We'll catch you the next time.